This is Mr. Humbard here, and today my video is going to be over the Chapter 2 reading guide. So, a coordinate system is a frame of reference The distance is just it's an arbitrary length between 2 points with no direction. No direction. Scalar. That's another way to say that. Just has a value. It is not a vector. So displacement is a distance with a direction that has an initial and final position. So displacement, or change in position, equals an initial or a final minus initial position. It's the exact definition. Speed is distance over time, and if it's the average speed, it's the average of a initial speed and a final speed put together. Average velocity, same story, but this time around it's a displacement over a change in time. A slope, if you have a position P and T plot, your slope is going to be the velocity as a change in position over change in time gives us the velocity. So m equals v for position versus time plot. All right, unit of measurements. For this, our unit of measurement of speed is meters over seconds using the SI units. Distance will be meters. Time will be in seconds. Velocity will be meters over seconds. And usually it will include a direction. But we're just talking about units, the direction doesn't matter. But I'll include the direction anyway, just to remind you it is a vector. Displacement, meters, direction as well. So the odometer measures distance, as it doesn't give you a direction, it just gives you a value of how many miles you've gone. And your final displacement could be 0. If you went somewhere, then you or if you started at a position, say 7 meters, then you traveled back, your final position was at 0, initial position was -7, your final position was at -7. Doesn't matter what you did in between. So your displacement can be 0. Distance is a scalar, displacement is a vector. So it has direction. The equation is going to be change in x equals x final minus x initial. So v equals the change in displacement, change in position, over the change in time. Change in x over change in time. Equation for motion. This is where you have an x final, then an x initial, and if you set this up, you'll get a velocity and a time. And if you solve this, you will get back change in x over some time, which I wrote time here as if you have a time starting from 0, then that turns into t minus initial time of 0. So we just call that t final t, usually. Anyway, that's it, I think. Let me check. Yeah.